Good evening, everybody. Myself, Dr. Shanda Mounty, GFGC Jevarki. In the last, we have discussed about the Cauchy's integral theorem, that is the fundamental theorem, the integral C f of z dz is equal to 0. Using the complex integral formula, now we will go for the examples. Integral C dz divided by z minus 2, where C is modulus of z is equal to 3. Let the integral dz is divided by z minus 2 is equal to integral C f of z divided by z minus z naught into z dz, where f of z is equal to 1 and z naught is equal to 2. Now, they are given the modulus of z is equal to 3, that is the circle having the radius of 3 with the center at the origin. For the point z dot is equal to 2 lies within the C because the radius is equal to 3. Then by using the Cauchy's integral formula, we can say that the integral C f of z dz divided by z minus z naught into dz is equal to 2 pi I into f of z naught. F of z naught is equal to 2, f of z naught value is equal to 1. So 2 pi I into 1 is equal to 2 pi I is the answer. For the same theorem, we can go for the second example. Integral C z minus 1 divided by z plus 1 into z minus 2 into dz, where C is modulus of z minus I equal to 2. Solution. Let z minus 1 divided by z plus 1 into z minus 2. This is the improper term. By using the partial fraction, we can have the solution as a divided by z plus 1 plus b divided by z minus 2. For finding the values of a and b, we have to put z is equal to minus 1 as well as z is equal to 2. For the same integral, we get a is equal to 2 by 3 and b is equal to 1 by 3. Therefore, the integral of z minus 1 divided by z plus 1 into z minus 2 into dz is equal to 2 by 3, the integral 1 divided by z plus 1 in dz plus 1 by 3, the integral c 1 divided by z minus 2 into dz. Here there are two terms, that is 1 divided by z plus 1 and 1 divided by z minus 2. For both the terms, we have to apply the Cauchy's integral formula or Cauchy's fundamental theorem. For that Cauchy's fundamental theorem, C is the circle with the center at I is equal to 0, 1 and the radius is 2. For the first term, that is the integral C 1 divided by z plus 1 into dz is equal to the integral C f of z divided by z minus z naught into dz. For this, comparing the integral f of z is equal to 1 and which is analytic on the and within the C because z naught is equal to minus 1. By using a Cauchy's integral theorem, integral C f of z divided by z minus z naught is into dz is equal to 2 pi I into f of z naught. 2 pi I into f of 1 and f of 1 value is equal to 1. Therefore, the integral C dz divided by z plus 1 is equal to 2 pi I. For the second term, that is the integral 1 divided by z minus 2 into dz is equal to integral f of z divided by z minus z naught into dz. Here f of z is equal to 1 and which is analytic. So z naught is equal to 2, which is outside the integral C. Therefore, 1 divided by 2 minus z minus 2 is analytic on and within the C. So the integral which is analytic and it is outside the C, therefore the Cauchy's integral 1 divided by z minus 2 into dz is equal to 0. Therefore, the main integral C z minus 1 divided by z plus 1 into z minus 2 dz is equal to 2 by 3 into 2 pi I plus 1 divided by 3 into 0, and that is equal to 4 pi I divided by